Hello there. So this is Dave Jamb Tutors again. So I am releasing another video again. The last video I explained universal sets, and I also explained some concepts concerning set theory. So now in this video I'm going to explain intersection of sets and union of sets. So but before I continue, I will first of all try to use this opportunity to explain some things before I start. So now we go into that. So and please don't forget to subscribe to this YouTube channel so you can be able to get notifications whenever I release a new video. Okay. So now, so first thing I would like to explain is this. If you have two sets like this, which are A and B, so whenever we have this middle part filled up like this, it means that this is A, this is A intersect B. That's what is called A intersect B. So, but whenever we have the whole parts of the two sets filled up, it's called A union B. Why it is called this is because this diagram, the Venn diagram, is always used to represent set notations. So, and you will see it mostly in your exams like Jamb. You will always see it mostly. It's always used to represent sets. So there are even at times that in a diagram like this, you see an equation here and you'll be asked to use it to solve a question. So this representation is what we call A union B. This is called union of a set. So now another thing I would like to explain is universal set. I had explained that earlier before. Universal set. Universal set is actually everything inside this box. It's everything here. That is the universal set. Everything inside is the universal set. So but whenever they speak of empty set is if there is nothing inside this box at all, it is an empty set. And it is represented with this sign. So whenever you see that sign is always an empty set. And at times always represented with a point bracket, with two point brackets containing nothing. It's always represented with that also. So another thing I would like to explain with this diagram is complement of a set. If I decide that I just want to fill A, and I don't want to fill any other thing apart from A, okay, let me draw another diagram so that you understand what I'm saying better. Sorry, let me just clean this part. So now, so let's say for instance, if they are not intertwined as I did it before, if they are different, so I just want to draw it like this. It's not always like this. I just want to draw it like that. So if they are different like this, so and I decide that I just want to fill up A. I just want to fill up A. I don't want to fill up anything left. So every other thing apart from this A I have filled up is the prime of A. So I can actually represent this diagram with A prime. I can represent it with A prime or A complement. So that is the representation of complement of a set. So another thing I would like to explain is um, I think that's all. That's all. So we know that the universal set is everything inside set. So the last thing is disjoint set. Disjoint set is anything that is not in this bracket. That is not inside this circle. Like everything outside here now, apart from what is inside these two circles, is what is called disjoint set. So just move on with us as we go into the video. So and if you don't understand, you just go back and play it so that you're going to understand. God bless you as you watch. so now from there we move directly into intersection of sets. So intersection of sets. This is a question of us. So now from our past knowledge we know that, like, let's take for instance, if this is x and this is z and this is y. Okay, so now we know that this point is always x intersect z. We know that this point is always y intersect z, and we also know that this point is always x intersect y. So knowing that fully well, so in this question now, they now said the shaded portion in the Venn diagram is, so, and this is the portion they have shaded. So this tells us automatically that that shaded portion is x intersect z. So now that we know it to be x intersect z now, so we can just mark our answer straight away. So, and that's what I've done here already. So the answer is x intersect z. Okay. So now we move into the second question. So the second question now says the shaded region in the Venn diagram above is. Okay, so now remember that I had said before that, like, there was a mistake in the question. This is actually P and this is Q. So now let me just write that. So this is P and this is Q. So this is R, not Q. This is R. So let's just take it as that. So now, as I had said earlier now, so we know that this is Q intersect P. So now they now said the shaded region in the diagram above is. So we already know our answer already. We know that our answer is B. So let's just mark that. So we know that our answer is B because this is Q and this is P. So, and we know that Q intersect P is this point. So, and that is our answer. So now that brings us to the end of intersection of sets. So now let's move to union of sets. Union of sets. So this is the first. Okay, let me go to simpler questions. I don't want to solve questions that are too difficult as I start them. Okay, so let me start with that one. So this first question says if x equals all prime factors of 44 and y equals all prime factors of 60, so the elements of x union y and x intersect y respectively are. Okay, so now they said x is all prime factors of 44. So we know that all prime factors of 44 are, just give me a second, x equals all prime factors of 44. So prime factors of 44 are 2 and 11. So because they are all numbers that can divide 44, numbers that make up 44 and are only divisible by themselves and 1. So that's x. So now they now said y equals all prime factors of 60. Y equals all prime factors of 60. And that is 2, 3, 5. So now they now said the elements x union y and x intersect y respectively are. So now x union y, now x union y means everything here and everything here. As I explained earlier, I explained it with a box. I drew 2 circles inside it and I said everything, if we say union, that means everything inside these two circles. So let me just clean that out. So now that we have that now, so if we now want to write x union y now, as they said in the question, so but you need to take note of something whenever you are writing your union. If you see two values that are in both of them, you are not supposed to write that value twice. You are supposed to write it once. So now we are going to write it out. So that is 2. So now that we have gotten our first 2, so that is 3, 5, 11. So as I explained before, remember I said it means everything in x and y. So it means everything that is in x and y is what I'm going to write out as the union. But if I find anything that exists in both, I will write it once. So, and that is what our answer is. Our answer is 2, 3, 5, 11. And that is A. That is A. Oh. I didn't include something. So they said all prime factors of 60. I forgot to include in this first one. I forgot to include 4. Sorry about that. All prime factors of 40. 4 is included. Oh, 4 is not included. Sorry. I'm on the right track. Our answer is D. Our answer is this: 2, 3, 5, 11, and 2. It is and 2 because of the extra 2 that is there. Remember I said because 2 exists in both of the Venn diagram, in both of the sets. So that is why it's there. So now let's move to another question. Another question on union of sets. So now this question says U equals x is a natural number from 1 to 20. Okay, we know that x is a natural number from 1 to 20. So p equals x are numbers divisible by 2. Okay, and q equals x are numbers divisible by 3. R now equals x are numbers divisible by 5. Okay, so now said find p union q union r complements. Using our knowledge of complements, he said we should find p union q union r complements. So that means what is not in p union q union r, that is what we are going to write in that curly bracket. So let me just write that at the top here. I won't put anything there yet, but in the process of solving the question, I'm going to put something there. So now let's first of all find our p. Let's first of all know what p is. So they said p is x equals numbers divisible by 2. So now numbers divisible by 2, and they said, okay, let me not write p first. Let me first of all write the universal set, because it's from the universal set we are going to get the value of orders. They said x equals natural numbers from 1 to 20. Let me write that out. 1 to 20. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let me not waste time on that. So you can just move the video a bit forward. This is giving me kind of a little bit of a problem. So I just move the video a bit forward. So you see that I've already done this already.
Okay, so now we have that now. So we have our universal set. Our universal set to be 1 to 20. So they now said P equals X are numbers divisible by 2. So P is all the numbers in the universal set that are divisible by 2. And that is all the even numbers. So let me just write that out also. So you can move it forward a bit. So they now said our Q are numbers divisible by 3. So numbers divisible by 3 in this. So let me not just waste much of your time because I don't want to waste much time here. Okay, so now that we have that, so we have all that now. So now we can now get our P union Q union R now. Let's write that out. P union Q union R equals open curly bracket. So now our P, we know our P to be 2, 4, 6, 8 and all that. And our Q is 3, 6, 9 and all that. So if we now want to write the union of everything, so this just tells us that the union of everything. Okay, so let's write that out. Let's write it out. That is 2, 3. I won't go back to them because I already have the value that it is. So I won't really go that much. I won't go back to it, just flipping forward and back that much. So I just believe that you follow, you try and understand as I go forward. So 2, 3, 4, 5, 6, 8, 9, 10, 12, 15. Oh, I've missed one. 12, 14, 15, 16, 18, 20, 16, 18, and 20. So we close our curly brackets. So now, this now that we have here is our P union Q union R. So remember that I had opened a curly bracket here for things that are not, which is the complement of P union Q union R. So if you want to find the complement of any value, you must first of all have the value itself before you now find the complement. So now, to find the complement of P union Q union R, so we have to look at the universal set and see what is not in what is in P union Q union R but is not in the universal set. As I mean, what I mean is this: what we have here but what is left in the universal set which is not here. So that is what I mean. So now, what we have in the universal set that is not there are 1, 7, 13,
wrap, and that's it for this video. So in the next video we're going to discuss on more intersection of sets and word problems. So enjoy the video as you go on, and don't forget to subscribe to this YouTube channel so that you're going to have access to more of our videos. Thank you for watching.